Good morning, this is Andy McLean with ASAT Incorporated doing business as Stove Tech, introducing the integrated stove. So this stove is brought to you by a grant from the EPA, and we've been working on this for several months. This is how the stove is fed for wood. We ignite the fire here down on the bottom, close the combustion chamber door. The wood is set inside a column that has a weight above it that feeds the fire at a specific rate. We've changed the weight of this to determine how fast the wood should be fed into the fire. You notice here we have fins on the feed chamber, so we do not have too much heat being built up in the feed chamber.
Thanks, Andy. I'm going to show everyone now about the thermoelectric generator. So the sticks are burning here, and we have some aluminum fins that poke up into the coal bed and into the bottom of the flaming sticks, and it gets very hot. And down here the heat travels to some pieces of silicon, and it's hot on one side, and this big radiator cools it on the other side. There's also a small fan that twists when the TEG powers up, and that helps with the cooling. So that's a little bit about how the electricity is made from the stove. More about the combustion is the fire happens here, and then it travels up the riser tube. A pot can be placed on top of the stove for cooking. Then the fire travels back down, and this whole cylinder gets hot and heats up the room, and then it goes out the chimney.
I'm Carl Walter. I'm with Waltech, a longtime partner of Aprovecho. And this is the sensor box. It's connected to the integrated stove, and it measures pretty much everything. It has carbon dioxide, carbon monoxide, and laser scattering particles. And then we've customized it so that it can also measure the voltage and power output from the thermoelectric generator. You get a nice graph here. Right now it's just showing ambient CO2. And a little extra bonus is that we added a web server so that we can have a graph on the phone, so everybody can watch the graph. And then this thing uses power from the TEG just to measure through it, and then it goes over to a load, which is an array of LEDs and a lamp. So that's about 30 watts worth of LEDs in the lamp. Once the power is monitored, besides the lamp load, we also are going to be able to connect to this and provide charging for 1 or even 2 cell phones. This is the intake from the sensing port. It has a dilution probe up above where it takes in some air and some of the sample and runs it down to the sensor box. And this in between on the stack is an electrostatic precipitator made by Okiotube. And this is the high voltage output from this box, and it's enough power, high voltage power, to charge the particles that come through here, and then they're attracted to the outside walls. So this electrode is an L shape and runs hangs down inside this 8-inch tube in order to charge the particles as they move up, and then they get stuck to the grounded internal tube, which pretty much cleans up between 60 and 90% of all particulates, if any, happen to come out of this very clean stove.